So say you're given the task of integrating sine cubed, right? Okay, well you can start off by realizing that 1 is equal to cosine squared x plus sine squared x, which isn't that useful right now, but if we write it as sine squared x is equal to 1 minus cosine squared x, well this is going to be really nice now, because now we can rewrite our integral as 1 minus cosine squared x sine x dx. And maybe you think this is harder right now, but it's actually not, because this allows us to do a substitution. So if we let u is equal to cosine x, and then du is going to equal to negative sine x dx. Again, this is just a substitution, and all we do is take the derivative of that substitution. Okay. Now, why don't we write this as negative du is equal to sine x dx, just so this can fit even a little bit better. And if you notice, we have sine x over here, sine x dx, and a sine x dx over here. So those are identically the same. Thus, we can now rewrite our integral. And also, let's use the fact that we call it cosine u. So this would be 1 minus u squared. And sine dx is this sine dx over here, which is equal to negative du. So negative du. Okay, now this is a lot easier to do, so we could rewrite this integral as u squared minus 1 du. And if we just factor out that negative, well, factor in that negative and just redistribute it, this is the exact same thing. Just looks cleaner. And if we integrate this, well, this is just a simple polynomial to integrate. Okay, and since we don't have any bounds, we need to reconvert back into what we had cosine. I mean, what we had u assigned to, which is cosine. So it'd be cosine cubed x divided by 3 minus cosine x. And of course, since this is a indefinite integral, we don't have any bounds. We have just plus c at the end. So this is exactly how you would solve a integral for sine cubed. And cosine cubed is very much the same thing.